Okay, my dear students, next we'll discuss about dielectrics and polarization. So first you understood what is the meaning of dielectrics. Dielectrics are the that is insulators which are having no charge carriers. ಅಂದ್ರೆ ಇಲ್ಲಿ charge carriers ಇರೋದಿಲ್ಲ, only these are having the dipoles. So therefore on the basis of this dipole there are two types of dielectrics, that is polar as well as non-polar. So polar dielectrics means these are the dielectrics made of polar molecules. Such dielectrics are called as polar dielectrics. So in a polar molecules ಅಂತಂದ್ರೆ ಏನು ಅಂತ ಹೇಳಿದ್ರೆ, these are the molecules having their centers of positive as well as negative charges are separated so that they have permanent dipole moment. For example, for the polar molecules are the molecules of HCl or a molecule of water are the examples. And the another type of dielectric is non-polar dielectric. These are the dielectrics made of non-polar molecules. So in the non-polar molecules ಅಂತ ಹೇಳಿದ್ರೆ, these are the molecules having the centers of the positive and the negative charges coincide. So therefore there is no permanent dipole moment. For example, for the non-polar molecules are molecules of oxygen and hydrogen. So just remember what you mean by polar and non-polar molecules with their examples. The next point that is related to the dielectric polarization. So andre ಇಲ್ಲಿ polarization ಅಂತ ಹೇಳಿದ್ರೆ, it is the phenomena of alignment of these molecules by an external electric field. So andre go through this figure. So the first figure, it is related to non-polar molecules, so in which the center of the positive and the negative charges are coincide, so therefore there is no dipole permanent dipole moment when E is equal to 0 here. When if you apply an external electric field for the non-polar molecules, initially the whatever external electric field is utilized for detachment of negative and positive charges. Then after that, by increasing the strength of the external electric field, the alignment of these molecules are in same direction. So therefore this alignment of these dipoles in a particular direction, this is called as a polarization. So therefore this polarization, that is percentage of polarization, it depends upon the strength of the external electric field. Similarly for polar molecules, so when there is no electric field, external electric field for the polar molecules, so this is the situation of the polar molecules, means they are in a random position. If you apply an external field for the polar molecules, then these molecules are will start to align in a particular direction. So therefore as the strength of the electric field goes on increase, then the alignment goes on increases. That alignment of these molecules in a particular direction is called as a polarization. Therefore the polarization goes on increases as the external electric field increases. Then on the basis of that, so this polarization, that is the dipole moment per unit volume, is called as a polarization. And this polarization, that is P, is directly proportional to the strength of external electric field, that is P is equal to psi E into E, where psi E is a electric susceptibility, it is a constant of proportionality. So andre, so this equation P is equal to psi E means, so the percentage of polarization increases if the electric field, external electric field goes on increases. So this equation is very important here. Okay, when the polarization takes place inside the polar as well as the non-polar molecules, this polarization will decreases the strength of the external field. Okay, okay, we'll stop here only. Thank you.